Welcome to Brain Vision.
In this question, we determine the smallest torque that must be applied to overcome the friction. So let's determine the smallest value of the torque. This question is related to uniform pressure. Uniform pressure. So for uniform pressure, the value of the torque. So the value of the torque expression is for double collar bearing is 2 by 3 coefficient of static friction. This is the load at A. This is RA. This is the radius, outer radius, minus inner radius. This is cube. Plus similarly 2 by 3 mu s, because this is a double collar bearing, so this is the load at collar B. Similarly this is RA, sorry, this is the RB, because this is the collar B and this is the collar A. So this is minus R, this is B, this is 1, this is cube, divided by RB, this is square, this is 2, this is RB. So the value of load at collar A is 0.75 P and the value of P is given as 16 kilonewton. Similarly, the load at collar B is 0.25 P. So this is 0.25, 1600, this is Newton. So this is the value of the load on collar B and A, and the coefficient of static friction is 0.2. Similarly, the radius is given in this question is RA. The outer radius of the collar A is 0.1 meter and the inner radius is 0.05 meter. Similarly, for collar B, the outer radius of the collar B is, and the inner radius for the collar B is. So substitute these value in this equation. We get the value of smallest torque. So the value of smallest torque is 237.33 Newton meter. This is the value of smallest torque that is obtained from the above equation, so that to overcome the friction. So this is the final answer.